Okay. So let's go ahead and go through these two. So what was probably the first play here? If you want to find cosine theta, tangent, or cosecant theta, or secant phi, okay, what was maybe the first thing that you might want to do?
Find this third side.
Okay, so Kirsten, you found this third side. I guess it doesn't really matter if I'm thinking of the angle theta, this would be the adjacent side. I'm just going to call the length A. Okay, and then what you know is that the sum of the squares of the legs, a squared plus 8 squared equals the square root of 89 squared. A squared is going to equal 89 minus the 8 squared, which is 64.
Which is 25.
You get 25, so A equals the square root of 25, which is 5. So using Pythagorean theorem, you'll get that base. The base has a length 5. And then now, cosine of the angle theta is going to be the adjacent side over the hypotenuse. So you should have got 5 over root 89. Okay. Tangent. What about tangent theta? What should you get for that one?
8 over 5.
Okay, that should just be 8/5, the opposite over adjacent. Now, how about cosecant theta?
It should just be the reverse.
Yeah. So it's the reciprocal of sine. Sine would be 8 over root 89. Cosecant is going to be the reciprocal of root 89 over 8. And secant phi is the reciprocal of cosine phi. Cosine phi is 8 over root 89. So actually, notice that cosecant theta and secant phi are the same. Okay. They're opposite angles in different corners. Okay.
No.
And then,
Because it's for phi.
okay, so again, cosine phi is 8 over root 89, so secant phi is the reciprocal again. And then how about finding theta? A couple different ways to do it. Brady.
Why is it secant a root 89 over 5?
Because it's for phi.
For secant? Because it's based on the angle phi. The angle phi is up in this corner. So how about I go through it a little more carefully. Secant of phi is really 1 over cosine phi. Okay. Cosine of phi is adjacent over hypotenuse. So this is 1 divided by 8 over root 89, which is just the reciprocal of root 89 over 8. So it comes from the definition of secant being 1 over cosine phi. Cosine phi is, so this is the angle phi, 8's the adjacent side. And you divide by root 89. 1 divided by a fraction is the same as the reciprocal of root 89 over 8. Yeah, Brandon?
Phi and beta are just interchangeable, right? From the examples you have beta, but then you have phi up there.
Yeah, actually, they're just arbitrary angles. I could label them with anything. Yeah. No, that's a good question, though. Later, we're going to have triangles that aren't right triangles, and you'll have theta, beta, and phi, or theta, beta, and gamma. So they're just arbitrary labels.
So like X and Y.
Yeah, just like X, Y, Z, W. Angles traditionally are just labeled with Greek letters instead of Roman alphabet letters, or letters from the Roman alphabet. Okay, so yeah, I could have used anything other than phi. I could have used beta, gamma, delta, any Greek symbol. Okay, so there's nothing special about it. Okay, so what about finding the angle theta?
Just
Tangent 8 over 5.
Okay, so Reed, you said just do arc. Did you say arc tangent?
Oh, you change it. Arc.
Yep, and then plug in the 8 over 5. Okay, perfect.
57.
And then anybody else do the same thing? Okay, and what did you get for a degree measure if you plug it in? 58? Okay. Actually, and is it exactly equal?
No, it's 57.99.
Oh yeah. So it's, I guess the directions say round it to the nearest whole degree.
Yeah.
Okay, so you get 58 degrees. And then what about now phi? So what's the trick? Once I know one angle is 58 degrees, I just take...
32, just minus 90.
Okay. So... Yep, so actually you can do it either way, right? You have two possibilities. One is take 90 degrees minus 58, or you can do arctan of 5/8. If you look up here, tangent phi will be 5/8, so phi will be arctan of 5/8. And rounded to 2 decimal places, I believe you said you should get 32 degrees? Okay. Or like I said, you could have done 90 degrees minus 58 degrees. Okay?
It's a really easy way to check your work.
Yes. Okay. And then the second problem, let me help everyone with the setup. Now, when I draw something, and later we're going to be doing more of these bearings problems. Okay? So this is kind of just a preview into those bearings problems. I like to work with everything up on my page is north, south, east, west. Okay? So just like on a map, right? So if I'm going to draw a picture of this, what I'll do is I'll say, here's maybe the water. Here's your little dock. And what the boat's going to do is, from the east direction, so this is what it means to rotate 44 degrees north of east. You start at the east and you rotate towards the north. Okay, so starting in an east position, I'm going to rotate 44 degrees to the north. And this will be our final position. That's the initial position, and this is now 44 degrees. And how long did it say we traveled? We went, yeah, so the final position to the ending position, this is going to be 12. That becomes your hypotenuse, really. Okay. And then when we answer this, we're going to say we went some number of miles to the east and some number of miles to the north. Okay. So we need to find, I'll just call it the adjacent side to the 44-degree angle and the opposite side. Okay. All right. And then, anybody want to share what they tried here, or what they did? Maddie?
So, because I already have 44, I figured I didn't need to find the other angle. So I did sine of 44 equals opposite over hypotenuse, because you have to use the hypotenuse to find the two other angles.
Okay. So you just set it up like this, right?
Yeah.
Sine 44.
And then it's, because that's just easier for me to just move the 12 over and multiply it by the sine of 44 degrees to find.
Yeah, I would agree with you 100%. That's perfect. Okay, that's exactly what I would have done. Okay. So since you're given the 44-degree angle and the hypotenuse, Maddie said, let's just apply sine to that angle and get op over 12. And then from there, you just multiply both sides by 12. And what did you get for that distance approximately?
I got 8.34 miles north.
Okay, so that distance, 8.34 miles, that's how far north we traveled, or this boat. And then what can I do to find the adjacent side, or the length that we traveled in the east direction?
The cosine of adjacent over 12.
So instead of applying sine to that angle, we'll apply cosine to that 44-degree angle to get adjacent over the 12 hypotenuse. So the length of the adjacent side is 12 cosine 44 degrees. And what did we get for that approximately?
8.63
8.63
miles east.
And yeah, you might just be careful, make sure you're always writing units if units are present in the problem. Okay? So we can say that the boat traveled at an angle of 44 degrees east of north for 12 miles, but we can also say that the direction traveled in relative to the north and east directions, let me see what the wording was. Find the position stating the boat's distance north and east of the dock. So the boat at its final position is, what did we say? So the adjacent side would be 8.63 miles east and 8.34 miles north. of the dock. Okay. That would be our final answer. So at the final position, the boat is 8.34 miles east, or 8.63 miles east and 8.34 miles north. Now, is that a sensible answer? Okay, 44 degrees is really close to a 45-degree angle. If the angle was 45 degrees, you would have gone the same distance east as you did north. And the distances east and north are relatively close to each other. So that answer makes sense. Okay. Anybody else have any other questions? Do we get to call it early? Since I probably owe everybody, what, a couple minutes times about 5 times by now?
Last quarter.
I probably still owe you from last quarter too. Okay, so we'll just call it early today. I'll be in the TLC 1:30 to 2:30. After that, I'll try and crank out the exams. But thanks everyone. Have a good rest of your day. Bye.